Hi everyone, myself Mahesh Shirur. This is the continuation of the shear problems. Okay, so a simply supported beam of span 7 meters is 120 mm by 220 mm in a section. It is P stressed by a parabolic cable which carries an effective processing force of 225 kN. The cable has maximum eccentricity of 100 mm at midspan and minimum eccentricity of 50 mm at this support. Determine the principal tension at 25 mm above the central fiber in a section of 0.7 meter from left support. The beam carries an all-inclusive loads of 12 kilonewton meter. So inclusive load means it includes the dead sulfate and live load. So this is the section of the beam longitudinal section, the UDL load. So here 0.7 meters. Got to find that, and this is CG, and from this CG 50 mm it has been located the wire, and from the center to cable at the center span is 100 mm eccentricity. Therefore, cross section of the beam is 120 by 220 mm. So given 225 kilonewton. So this is 700 mm, then 50 mm from the center. Okay, CG, and this is the E value, and this is the Y value. Okay, so Y is equal to 4H upon L square into X into L minus X, as you studied in this POC. Okay, therefore Y is equal to 4 into 50 into 7000 mm square into 700 into 7000 minus of 700, that is equal to 18 mm. Therefore, E upon X is equal to 0.7 7 meters, that is equal to 15 plus 18, that is equal to 68 mm. First it was 50 mm at sensitivity plus due to that y deflection y, that is equal to plus 18 is equal to 68 mm. And slope dy by dx is equal to 4h into L square into L minus x. Okay, slope upon x is equal to 0.7 meters. Therefore, dy by dx is equal to tan theta, that is equal to sin theta. Since theta's value is very small, tan theta stands to sin theta. Okay, and therefore 4 into 100 minus 50 divided by 7000 square into 7000 minus 50 into 700, sin theta is equal to 0.023. Therefore, now ultimate shear force V equal to W into L upon 2. So W is 18, length is 7 divided by 2, that is 63 kilonewton. Then Mi, that is moment of inertia, I is equal to BDQ upon 12, breadth is 120, depth is 220, cube divided by 12, that is equal to 106.48 into 10 raised to 6 mm raised to 4. Then shear stress calculation, shear stress is equal to, so this is 120, this is CG, so 85 plus 25 equal to 100 mm, 110 mm. This is y bar to v equal to v into a into y bar divided by I into b. So a into y bar is equal to 120 into 85 into 85 divided by 2 plus of 25, that a into y bar is equal to 688.5 into 10 raised to 3. Now breadth is equal to 120 mm. Okay, so this is at this distance of 0.7. To find that at both sides 63 kilonewton, and this is total load is 12.5, factor load is 1.5, that is 12 into 1.5, 18 kilonewton per meter. Therefore, shear force is equal to 63 minus of 18 into 0.7, 50.4 kilonewton. Then bending momentum is 63 into 0.7, that minus of 18 into 0.7 into 0.7 divided by 2, that is 39.6 kilonewton meter. Therefore, net shear force at x is equal to 0.7. Therefore, V equal to 50.4 minus P sin theta. V equal to 50.4 minus 225 into 0.023. Therefore, V equal to 45.22 kilonewton. And to V equal to 45.22 into 10 raised to 3 into 688.5 into 10 raised to 3 divided by 106.48 into 10 raised to 6, that is into 120. Therefore, to equal to 43 Newton per mm square. Then principal stress is equal to Fx in horizontal. Principal stress at x is equal to 0.7 meters. F of x p by a minus p by z. Z is equal to I by y plus m upon I into y. So p is 225 times 3. Here is 120 into 220 minus of p is 225 into 10 raised to 3. E is 68 divided by is 106.48 into 10 raised to 6 into 25. Y is therefore m is 13.6 into 6 into 10 raised to 6 divided by I is 106.48 into 10 raised to 6 into 25. Therefore, Fx is equal to 14.24 Newton per mm square. Therefore, maximum to stress maximum minimum is equal to Fx plus Fy divided by 2 plus or minus half into root of Fx minus Fy the whole square plus 4 into 2 square. So putting this value is 14.24 plus 0 divided by 2 plus or minus half into root of 14.24 minus 0 the whole square plus 4 into 2.4 the square. So to maximum is equal to 14.64 Newton per mm square. Minimum is equal to 0.40 Newton per mm square. Next one, the cross section of a pre-stressed concrete beam is rectangular with a width of 350 mm and an overall depth of 700 mm. The pre-stressing force of 180 kN acts as an eccentricity of 180 mm. If the bending and twisting moment at the section are 80 and 20 kN respectively, calculate the maximum principal tensile stress at this section. Area is 350 into 700, that is 245 into 10 to 3 mm square. I is equal to BD cube by 12, that is 350 into 700 cube divided by 12, that is 10 into 10 to 9 mm raised to 4. Then shear stress due to torque at the support of the soffit of the beam is given by tau T equal to capital T into alpha into h into b square, that is called T divided by length into breadth into d square, where T equal to 20 kilonewton meter, B is equal to 700 mm, H is equal to 350 mm. For ratio B upon H is equal to 700 divided by 350, that is equal to from the table, okay, D by from the table we'll get D by B, or for B by H equal to 2 or alpha equal to 0.217. Tau T equal to 2026 divided by 0.217 into 350 into 700 square, that is 0.537 Newton per mm square. So B by H and alpha 1 equal to 0.208, for B by H 2.2, alpha equal to 0.219. Therefore, the compressor stress due to pre-stressing force at the soffit of the beam is given by Fc into Fb minus P by A plus P by I into I bar. So Fb or Fc equal to 180, P by is 180 into 10 raised to 3 divided by 245 into 10 raised to 3 plus of P is 180 into 10 raised to 3 into E equal to 190. Y bar is equal to 350 divided by I is equal to 10 into 10 raised to 9. That is equal to 0.734 plus 1.197. Okay, that is equal to 1.931 Newton per mm square. Next one, tensile stress at the surface due to the bending moment, that is equal to m by into I bar. So m is 80 into 10 raised to 6 into 350 y bar. I 10 into 10 raised to 9. That is 2.8 Newton per mm square. The horizontal stress is equal to at the surface 1.93, that is Fx is equal to P by A plus P by I into Y minus M upon I into Y. So 1.93 minus 2.8, that is equal to minus 0.87 Newton per mm square tension. Principal tensile stress at the surface is equal to F minimum minus 0.87 divided by 2 minus of half into root of minus 0.87 square plus 4 into tau v square. So F minimum is equal to minus 4 minus 0.435 minus half into root of 0.756 plus 4 into 0.537 the square. F minimum is equal to minus 1.125 Newton per mm square. Okay, thank you.